So in this video we will talk about SIM packages. So before going to the details of SIM packages, let's try to first understand how SIM XML file is created and how various applications utilize the generated SIM XML file. So the SIM XML file creation steps are as follows. We will first identify the SIM classes and attributes required for a particular data exchange. Since as we know that in common information model we have close to 1500 classes and all classes are not utilized for the particular data exchange. So one particular data exchange will require very less number of classes. So for that we have to first identify the required classes which are necessary for a particular data communication and the corresponding attributes which will help in identifying the required parameters to be collected. Then after identifying the classes and their attributes, we will generate the corresponding SIM profile. That means we will utilize the inheritance, association or the aggregation properties and connect various classes with each other. So in this way we will generate the SIM profile. After generating the SIM profile, we will develop the SIM XML schema, which will be nothing but a template with blank tags where we will fill up the required data. So this template, that is SIM-XML schema, has to be agreed upon by the stakeholders, means those who are publishing the SIM-XML schema and those who are subscribing to that SIM-XML schema. So that means that the stakeholders who are responsible to generate the data and those who are responsible to consume the data both have to agree upon the standard SIM XML template so that they can send and receive the data in that particular format. Then the applications which are not SIM compliant, they need to develop the plugins, that is small software applications which can convert the standard SIM data into proprietary local data which is being consumed by the individual applications. So this plugin will help in creating and parsing the SIM XML file. One such kind of XML schema is shown pictorially in this figure, where these are the various tags in which a particular data will be pegged. Now let's try to understand how the XML schema is generated and it is shared with various applications and what are the various activities involved in publishing and subscribing the required SIM XML data. So suppose you have one setup where you will have lot of software applications connected through one common bus, which is nothing but enterprise service bus, where the data travels, and then from that enterprise service bus various software applications receive the data. Now suppose the GIS, that is Geographical Information System application, is a publisher of a particular data. So this application will obtain data from the GIS application or from the database of the application, and then it will transform the data into a SIM XML format, and then this same XML file will be sent to various subscribers. So now you will see here that the applications which is not SIM compliant will have to map the proprietary data into a SIM XML compliant data format. So what will happen in that case, the application data and the corresponding CMXML data have to be mapped properly, and this information will now be in a standard format, which is nothing but the data which is being generated by the proprietary application. The role of SIM is that it will convert the proprietary data into a standard data. Now, this standard data is understood by all the SIM compliant applications because they know that what does this data means. Now, this application is publishing the data at the enterprise service bus, and all the subscribers who are there connected with the enterprise service bus will receive this same XML file. So now GIS is pushing data to the enterprise service bus, and then various other applications, say outage management system or energy management system or any outage reporting application or event history applications will receive the data. Now, since event history is the SIM compliant application, it will directly consume the SIM data because it knows what does this data mean. While in case of other legacy applications, since they cannot understand the standard SIM data, they have to first develop the plugin, which will be nothing but a software adapter. The role of this software adapter is that once they receive the XML file, the XML file will be parsed and the required data will be pulled from that XML file, and then the mapping of the data happens. Say this is the data set which is being shared by GIS application. Out of that, the same data, there might be few data points which needs to be consumed by this application, so that the plugin or the software adapter will map the corresponding fields or the data points with the application data points which are native to this application. So what will happen, the only those data points which are required will be mapped and will be consumed by this application. The same will happen to other applications also. Say in this case, the first two data points are the data points which are required for EMS application. So the adapter will map this standard SIM data into a proprietary application data, and this proprietary data will then be consumed by the application. So this will happen to all such kind of applications which do not have the SIM compliance. What are the various SIM packages? So we have three major SIM packages as we discussed in the previous video also. We have IC 61970, we have 61968, and then we have IC 62325. 61970 is for transmission, 61968 for distribution, and 62325 is for the market operations. From where you will get the SIM package? If you go to the website of SIM user group, then you will be able to download some SIM packages, and when you explore those SIM packages using any standard UML software, say for example you can utilize enterprise architect software. When you open this SIM package which you have downloaded from SIM user group website and explore, you will see this kind of structure in the SIM package. Now when you further explore these folders, then you will see various subfolders inside these packages. So let's first explore the IC61970 folder. When you explore, you will see a lot of subfolders are there which are containing classes related to a particular application or the activity. Say the SCADA folder will contain the classes related to SCADA application. MES folder will contain all the measurement related classes. Topology folder will contain topology related classes. So when you explore all these folders, you can further see what are the various classes in those folders. IEC 61970 can be categorized into three major subsections. First section is the information and semantic model, which is conforming to IEC 61970-301. So that is basically the same UML model which we just saw in the previous slide. So this will contain information model, and it will define all concepts needed for the exchange of various power system applications such as load flow and so on. So this will have various reused parts. You can even add new extension to this sim UML. So new extensions means if you see you want some new classes to be created particularly for new equipment, then you can extend this sim UML. Now after the semantic model, you want the context. That means you need various profiles. So in IC 61970-452, 453 and 456, there are various power system model related profiles are already created, which are commonly being utilized for any software related data exchange. So we can utilize those standard profiles which are available in these subsections of IC 61970, or if it is required, we can create our own profile for a particular required data exchange. So what power system model profile group will give you? It will set the contextual layer which restricts the information model. That means it will contain the limited number of classes which will define a particular profile and related data exchange. So it will specify what part of SIM is used for any particular model exchange. It has mandatory and the optional features. It has various restrictions added in that, but these will be local to you. It cannot be added to the standard information model. Now after the profile, you need the SIM schema. Here we use another type of XML document which is called as RDF, that is resource description framework. So we will see in future slides what does RDF means and why we use it. So particularly RDF is required in the SIM because the standard SIM XML file cannot give you the hierarchical relationship. So for that, the relationship needs to be maintained using RDF schema. So basically the message syntax will conform to IC 61970-501 and 552. So this will tell you what different SIM XML model exchange formats we can utilize, how we can label or relabel the elements. We can change the association to define the message payloads, and mapping to various technologies can be defined. There are various profile groups in 61970. Say 61970-456 profile group contains profiles related to state variables, measurement set and topology. 452 contains measurement specifications, equipment model, boundary object, common object and schedules. 453 will contain the semantic layout, and the future profiles, that is the dynamic models, are in 45x, which are still to be named. The most common profile which we utilize in SIM data exchange is 61970-452, which is known as common power system model, that is CPSM profile. So this specifies the profile of SIM for exchange of static power system data between utilities, security coordinators and other entities participating in the interconnected power system. All parties have access to the modeling of their neighbors' systems that is necessary to execute the state estimation or power flow applications. The companion standard, that is 61970-552, defines the SIM-XML model exchange format based on RDF, that is Resource Description Framework, that is the RDF schema specification language that can be used to transfer power system model data for a particular profile. IC 61968 SIM packages. So in 61968 SIM package, we can arrange the folders into various parts. Operations folder is part of part 3, 4 and 5. In part 4, mainly the asset related folders are arranged. Part 5 and 7 talks about the planning. Part 6 talks about work. Part 8 related to customers. Part 9 related to metering, load control and payment metering related activities. So corresponding to individual activities, we will have corresponding folders, and when we further explore those folders, we will get the required profiles as well as the classes. IC 61968-1, that is the interface reference model. This interface reference model provides the framework for identifying the information exchange requirements among various utility business functions. So now you can see that in the middle you will have the middleware, which is nothing but enterprise service bus, and now we have various software applications related to the distribution system. Then we have various standard interfaces which will define how the particular application will exchange data to the middleware. So say for example, network operation is defined in part 3 of the standard. So interface standard will be covered in part 3 of the IC 61968. Similarly, asset management is in part 4, operations in part 5, maintenance and construction is in part 6. Similarly, network extension planning is part of the part 7 of the model. Then customer support is in part 8, meter reading and control is in part 9. So this figure will help you to understand that the interface standards which are required to share data into a standard format will be defined in these parts of the reference model. Now let's see IC 62325, that is SIM market extensions package. So in IC 62325 folder, when you explore, you will see the various classes and their attributes related to energy market. So if you explore capacity allocation and nomination folder, you will see there are a lot of sub folders, and if you further explore, you will see various classes available in those folders. Say you will see bit assembly model, write assembly model, capacity assembly model, implicit auction result assembly model, total allocation result assembly model, and so on. So each classes and their corresponding attributes you can further explore while exploring the package.